appreciate Microsol inviting me to do this presentation today. I'm excited about it, and thanks to all of you for taking time out of your busy schedule to join us today. So as was mentioned, I'm going to be giving a presentation today, sharing with you a presentation entitled BIM in the Era of Connection. So if you're listening today, I like to believe that you have at least embraced BIM somewhat. We'll be kind of taking BIM to that next level and talking about the power involved when you move it on up and fully embrace the power of the cloud. And we'll be talking about that and what that means to you. You know, getting into collaboration and adding insight into the design decisions and so on and so forth. And before we do that, I always like to kind of kick it off by talking a little bit about this whole concept of disruption. If you've heard me do my Future of Making Things presentation, I talk about disruption. We hear the word disruption and we think of negative things, right? We've been taught our whole life not to disrupt. That's a bad thing. But when it comes to technology and innovation, disruption can actually lead to some pretty good things. And I'm sure that you can think of technology in your life that has been very uncomfortable at first, but has led to some pretty good things. But definitely has disrupted our world. I mean, cell phones disrupted our world, TVs disrupted our world, cars disrupted our world. We can think about all different types of technology that has entered, but eventually, I would argue, made the world a better place. And I found this up on the internet, so it must be true. I grabbed this definition for you. A disruptive innovation is an innovation that helps create a new market and value network. See, that's a good thing. It opens doors. It opens opportunities and eventually disrupts an existing market and value network. That's usually the uncomfortable part. It could take a few years, it could take decades, but eventually it displaces an earlier technology. And some of us have lived through this when it comes to the world of CAD. Some of you might remember the hand drafting days. Some of you might have actually done some hand drafting. And I became involved in the early days of AutoCAD. I actually never did hand drafting myself. I literally started in the early days of AutoCAD, and I started teaching AutoCAD. And I had such a hard time understanding why people didn't just jump on board with CAD and fully embrace this amazing new technology. And I was very disruptive. I was a huge disruptor. And it was a very difficult task for people to embrace making the move from drawing on paper, to drawing using a software product. And in the early days of CAD, I wasn't just teaching people how to draw using a software product. I was actually teaching people how to use a computer because computers were new as well. I would tell somebody to hit F1 and they would literally hit the F key and then they would hit the 1 key. I mean, they didn't understand a keyboard at all. So it was a huge learning curve. It was a very disruptive technology, and it was very painful. And I had more than one student, stand up in class and say, hey, this CAD thing's never going to catch on. I had students who left my class. I don't know, maybe I wasn't a very good teacher. Who knows? But it was very, very disruptive and uncomfortable. And there were a lot of people who thought it would never catch on. Of course, I would argue that, governments came along and started mandating DWG as the format, and and more companies started mandating DWG. And I don't think any of us doubt that this whole CAD thing did catch on. I don't think we doubt it at all now. But it was very, very disruptive. But it did open a lot of doors and a lot of opportunity. I don't think, once again, that we doubt that it caught on at this point in time. But many of us have had to go through this whole cycle again. So yeah, we fully embraced AutoCAD, in most cases AutoCAD, and some type of CAD. We jumped on board and we learned the product. We got to know it really well. And then along comes this whole concept of BIM, this building information modeling, this whole different process, completely different from CAD. I mean, CAD is really just lines, arcs, and circles. It's really just replacing pen and paper or pencil and paper. Whereas BIM is a completely different mindset and a completely different process. And some of you might even still be going through this, trying to make that change. Or maybe you haven't even made the change yet. But also very, very disruptive. The same thing is happening though, right? Governments are mandating a certain level of BIM. And you can definitely see that the world is making the move to BIM. And hopefully, most of you have embraced BIM and have jumped on board, because I promise you that's the way the world is moving. But, uncomfortable, disruptive, but it's definitely led to such an improvement in our designs, and, the world is a better place because of it. It's just that simple. And so, once again, disruptive. So we're going to be taking a look at some more disruptive technologies today as I share with you this whole concept of BIM in the era of connection. And I want to make sure you're kind of open-minded as we go through these. Some of these technologies might be far out in the future for you, but some of them could be tomorrow. And I'm hoping that you will be open-minded as we take a look at them. And some of them will be, you'll completely get it, and you'll go, oh man, I just wish I had that. I could use it right now. And once again, some of them are going to be a little far-fetched out there. But I want to share with you what some of your other companies in the industry are doing, and some amazing things that they're doing. And open your minds a little bit. It's a fun presentation. I think you'll enjoy it. So before we go any further, though, let's take a look at some global trends and why it's so important that we look at these disruptors and we take a look at these other technologies. So let's take a look at the future. So right now we have a population of about 7.5 billion people, right? But by the year 2050, it's believed we're going to be somewhere around 9 billion people. And about 2.5 billion of these people are going to be living in cities. And then if you like heat maps, I like heat maps. This kind of gives you some idea of where we were in 2014. You can see the distribution of the population of the world. And here we are in 2050. I actually think it's easier to take a look at the delta. Here's the change here. You can see there's going to be quite a bit of growth. Now, what does that mean? If you take a look, that's a big chunk of population growth. In order to keep up with this type of population growth, we literally have to build 1,000 buildings a day, if you can imagine that. And that equates to about $3.3 trillion that we would have to invest in things like roads and energy and water and telecom, transportation, for example, and other infrastructure between now and the year 2050, just to keep up. I mean, just to keep up. So that's kind of a scary thought. We need to really, really jump on the bandwagon. And if you take a look at how much just the construction industry, for example, invests in technology, I just want you to see that there's a very low investment in technology, which is going to make it really, really hard for us to keep up. Okay, but the good news is we are above agriculture and hunting. So we're not at the bottom. That part's good. We're not at the very bottom. But that's not going to be good enough for us to keep up. So it's believed that if we could just embrace technology, if we could really make that move to a fully digital process, that we could save $1.2 trillion a year. And that would also, once again, help us keep up with this population growth and help us build all those buildings that we need to sustain the increased population. And let's take a look at some other, I like facts and figures. I have a degree in math. I'm kind of big into facts and figures. So on construction sites alone, there are more than 220 million workers in the field executing projects. Okay, so despite of, and partially because of this, extremely large workforce. I mean, there's a lot of problems when it comes to execution. There's a lot of waste, 40% material waste. That's sad. We've all seen it on construction sites, regardless of where you are in the design process. You've all visited a construction site, and you know that there's a lot of waste that happens. There's a lot of delays that happen. The average schedule overrun is 20%. Okay, that's pretty serious. 80% of owners expect some type of added cost. That just kind of comes with the territory. They just expect it. That's sad. And there's an average cost increase of 3 to 5%. I almost feel like that's a low number, but that just kind of is a given as well. They know that things are going to go over budget. And these facts and figures, incidentally, are all courtesy of McGraw-Hill and Kinby, just so you know. And I just liked this picture, so I threw it in here because I thought it resonated. Many of you can relate to this. You can see that great big beautiful yacht that says change order on it. And then you see the little tiny dinghy that says original contract. So many of you can relate to this, just to kind of hone this in. And once again, if we fully embrace technology, which we can do, it wouldn't look like this. It wouldn't go like this. So the Boston Consulting Group believes that if we did full-scale digitalization in construction, that we could reduce the annual global cost of engineering construction by 13 to 21%. So once again, the more we invest in technology, ultimately, the more money we could save. So somewhere in here, we need to start focusing on investing in more technology. And I know you feel like you've invested in technology, right? You know, you're doing your models in software, but we need to really take it to the next level. We need to get organized. We need to embrace technology. And as I'm looking at this picture, I'm thinking, that's an old computer. She needs to embrace newer technology. Am I right? So, connected BIM, that's really why we're here. We're here to talk about this connected BIM concept for the entire life cycle of the project, the design, the build, and the operate when we do the handover. What exactly does this connected BIM mean? This is a phrase that we throw around a lot at Autodesk, but I want to make sure that you understand when we say BIM in the era of connection or connected BIM, we're really talking about kicking it up. It's really BIM plus the power of the cloud, okay? Really embracing everything that the cloud has to offer. So we're going to talk about all the different things that the cloud has to offer when it comes to BIM and what that means to you. Because, you know, we hear a lot about the cloud. Cloud, 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 cloud. It seems like everywhere we turn, we hear about the cloud. So what is the cloud, right? It's those 60 million servers out there that we have access to. And, you know, no longer are we limited to the computer that your boss decides you're worthy of, or your budget decides you're worthy of, or whatever you have in front of you, because now you can access those amazingly fast, speedy, powerful supercomputers out there, and you can do things, once again, that you could never do before. The cloud allows us to do all kinds of things, and we're going to take a look at the 3 different areas that I think the cloud is the most powerful at. But before we do that, I always like to just throw out a little bit of trivia out there. Why do we call it the cloud? Because have you ever wondered why we call it the cloud? I mean, I think it's a good name. I think it symbolizes it if you think about it. The cloud was a good name, but you know, why do we call it the cloud? Why don't we call it the moon or the stars or the carpet or the, I don't know, the tree? Why do we call it the cloud? So in case you guys are on Cloud Jeopardy, I'm going to give you the answer to this. So I've been talking about the cloud for many years, so I had to know why we called it the cloud. It was important to me. It's a great dinner conversation. Not really. Most people don't care. I care. I'm going to tell you, we call it the cloud because of this guy right here, John McCarthy. He's known as the father of cloud computing. And back in the year 1961, he made a prediction. He predicted that someday computation would be organized in the same way as a public utility. And you're saying, what, Lynn, does that have to do with the cloud? I don't blame you, because it doesn't make any sense yet. Let me tell you a little bit about John McCarthy. He was a professor at Stanford. He was a very well known, very well respected man. We're going to talk about him in a little bit more detail in just a bit. But he did make this futuristic, view of the way our future would look. So what is he talking about? It was computation would act in the same way as we access our utilities. What the heck does that mean? So think about the way we access our utilities. You know, electricity, for example, we plug in when we want to access it, and we unplug it when we don't want to access it. And in some cases, you know, we pay for what we access, right? Now, I don't actually have a power plant in my backyard. I hope that you don't have a power plant in your backyard. But I can access the power because of this network, right? So I can access my software the same way I access my utilities over the internet, right? I can get access to my software. I can access it when I'm plugged in, and I can't access it when I don't have a network connection, right? Does that kind of make sense? So he was specifically referring to the telephone industry when he gave this huge prediction that we would be able to access this computing power the same way we could access our utilities. He was specifically referring to the telephone industry. And just so you know, in the early days of the telephone industry, that particular network, the telephone network, was referred to as, guess what, the cloud. So 100 years ago, that telephone industry was referred to as the cloud. And so he referred to it as the cloud, and that is why we call it the cloud today. So once again, great dinner conversation. And for those of you who are AutoCAD folks out there, I just thought I'd share with you that John McCarthy is also known as the father of artificial intelligence, and he wrote the programming language Lisp. So if you ever did any programming in Autolisp on AutoCAD, this is the guy you can thank for it. And he also is the person that wrote the very first chess game that you could play against a computer. For those of you who ever saw 2001 Space Odyssey, he's kind of, you know, he's the one, when robots take over, machines take over the world, he's the one that started it all, okay? So there's a little bit of trivia for you. So a little concept there as far as the cloud is concerned. So there are 3 areas that I believe that the cloud, according to Lynn, the cloud, according to Lynn, adds value to us as it relates to building information modeling, the world of BIM. The mobile aspect of it, the ability to access our data from anywhere, anytime, anywhere, right? Hopefully you've been able to take advantage of some of that as a result of the cloud. The collaboration aspect, we'll be talking a lot about that. That's probably why most of you tuned in today. So we'll be talking a lot about the collaboration aspect of it. But, you know, no longer are you restricted to working with design teams that you can physically get to. Now you can work with people all over the world as long as they have access to the cloud or they have an internet connection, right? So, you know, that comes with its own set of challenges, of course, and we'll talk about that. But nevertheless, the cloud allows us to collaborate with people all over the world. And then this whole concept of infinite computing, okay, that to me is the most powerful aspect of the cloud, because now we can do things that we just couldn't do before. We're no longer, once again, limited to our hardware. We can think out of the box and do some pretty impressive things as a result of having access to those 60 million servers. I'm going to start off talking about infinite computing, and we'll give you an example that I'm pretty sure you can relate to. This is actually a picture that I physically took when I was in South Africa. I was visiting a university, and this was a little note that was on a desk. And I'm sure many of you can relate to this if you've ever done rendering, you know, 5+ years ago, or hopefully not too recently. Renderings could take hours, they could take days, they could take weeks. And once you started a render, you certainly didn't want anybody to mess it up, because then you'd have to start all over again. Which, you know, you can imagine if it's a project that took days, you certainly didn't want to have to start all over again. And that's where this picture came from. So rendering is a perfect example of something where the cloud can really, really come in handy, right? Because you can just take all the information that you need, send it up into the cloud, and let the cloud do all the work for you. Let's not force our poor computer to try to churn away and come up with that rendering. Rendering is very compute intensive. Let's let the cloud do that. That's a perfect example of where the cloud comes in handy. And I just love this visualization. This is a visualization that, you know, 10, 15 years ago would have taken days. This rendering would have taken days. This happens to be a Moscow power plant that they're turning into a cultural art space. This is done by the Renzo Piano Building Workshop. I'm sure many of you are familiar with them. They've done the Harvard Art Museum, the California Academy of Sciences, the Nemo Museum, if you've ever been to Amsterdam, which is a huge tourist attraction. They've done all different types of, very, very famous, right? And this is a very beautiful rendering. It's extremely clear. The communication, to me, is very clear. We understand the intent. And when you're communicating designs, you want that intent to be as clear as possible so everybody's on the same page. And I would argue that communication in design is incredibly important throughout the entire life cycle of that building. So many of us do rely on renderings to communicate our ideas. So something that used to take days or weeks now takes minutes, because you can very easily take all the information you need to do a rendering, throw that up into the cloud, takes minutes. Let the super servers do it, right? All right, and then I just thought I'd throw this in here because I do find this amusing, and because watching webcasts can get boring. Believe it, did you know that half of the images in the IKEA catalog are actually computer-generated images. They're not photographs. That's why when you buy something from IKEA, you can't put it together. That's why, because it may have never ever been put together. It may have always been a computer-generated image that nobody was ever able to put together. So anyway, but that's just to illustrate the power of the renderings that we have nowadays. They can look just like photographs. You know, they look very, very realistic. So, and then what is this? Okay, so I love this example. This is one of my favorite examples. This is a mess. That's what this is. Let me set this story up for you. Every year, 100,000 people die as a result of infections that they get from the operating room table. Okay, and you can kind of see why here. You can see where the operating room table is here. You can see all those the images that you're looking at. That is showing you the airflow in that operating room, and you know the airflow is going everywhere. And you can see that that poor patient really doesn't stand a chance. And what you're looking at is an illustration of this airflow and something called CFD, computational fluid dynamics, which I just like to say because it makes me sound super intelligent. Computational fluid dynamics. It's amazing technology. It's something that was reserved only for supercomputers in the past and only for super, super smart people in the past. It's something that now you or I can do on our computers as a result of the cloud. So 100,000 people is a lot of people, and that's a terrible statistic. It also happens to cost the health industry over $3 billion a year as a result as well. So if you have no empathy for lost lives, which I hope we all do, then you can understand the financial aspect of it is also very painful for the industry. So a wonderful company called Hunt Air came along, an HVAC company, and they said, we can do better. Let's figure out how to direct the air away from the patient. What if we could do that? What if we could even save half that many lives? I mean, I don't even know if you can visualize 100,000 people. Can you imagine that? Let's take the size of a stadium. If a 747 crashed 4 days a week, every week for a year, that is 100,000 people. And that would be pretty big news, right? So this is like a top secret, fact that most people don't know about. So Hunt Air came in and they said, we're going to fix this. So they studied clean rooms, and using CFD, they took a look and they figured out how they could route the air away from the patient. And they, once again, did this by harnessing the power of the cloud. And they, came up with this new design that they're sharing with hospitals all over the country. And as, what if they could just cut that number in half? Wouldn't that be amazing? That would be amazing. So that's also as a result of the cloud. Okay, so now you may not be designing hospitals and you may not be saving lives like this, but you are designing buildings, right? And I'm sure many of you care about the airflow in your buildings. Some of you might find it helpful to be able to take a look at how the airflow would affect the people in your buildings, right? Wouldn't that be nice? I stay in a lot of hotels, and I can tell you the airflow in most hotel rooms are terrible, So this is being able to, really put yourself in the place of these people and see the effect of the HVAC systems on the people. So CFD, the power of the cloud. All right, so and these are, a little out of the box, but something that I promise you in the next few years will be used more and more and more and more. All right, also taking a look at infinite computing aspect of the cloud, something called generative design. My dog is scratching at the door. No, so you can tell this is live. So generative design is a concept that Autodesk has invested a lot in, and we're very focused on taking this to the next level, and you're going to be hearing more and more about this. This is a really interesting concept. This is a situation where you don't tell the computer what you want it to do. You basically tell it what the goal is, what you want it to accomplish. You might give it some parameters. We want a building made out of this material. We want it to be this energy efficient. We want it to cost this much money. You could give it a whole bunch of parameters and see what type of design, for example, it might come back at for you. It might come up with some ideas. It might trigger some thoughts for you. It may not come up with the ultimate solution, but it might come up with some ideas that might help you be more successful in coming up with your own design. Or it might come up with the perfect solution. You don't get to step away. You don't get to not do your job. You are still critically important in this process because it's going to come back with hundreds or thousands of design options. You still need to be the smart one, and you still need to make the final decision. But having the computer, weigh in and come up with some alternatives can really come in handy. I think about if you've ever been to the Sydney Opera House, and you know that whole story with the Opera House with Jorn Utzon, where you came up with this amazing design, but it took them years to try to figure out how to build it. How great would it have been if generative design was around back then and they could have plugged this in and possibly come up with a way to build it sooner, or an alternative before they finally came up with the amazing orange peel scenario. But maybe they would have, maybe they wouldn't have, but it's a pretty interesting concept. Now, I'm going to give you an example that is not AEC related, just because it's the perfect example in my mind. And then I'll give you an example that is AEC related. So this has to do with the Airbus A320 planes. This is a partition, and most of you, if not all of you, have been on an airplane before. The partition separates the cabins, right? And it serves as a jump seat for the flight attendant. Okay, there's nothing wrong with this partition that's currently being used. It's lightweight, it's strong, but what if we could make it lighter and stronger? Okay, this is the perfect scenario for generative design. To hand it over to the computer and say, here's the deal, we want it lighter and stronger. Let's see what you could come up with. So that is exactly what we did. We worked with Airbus. They said that we could work with them on this and see if we could come up with a better solution. Right, so we handed it over to the computer. We did give it some information, some parameters, a crazy parameter. We actually gave it this whole concept of living systems, specifically bacteria. Bacteria is very lightweight, super bonding, super strong. So we did throw that into the mix for it to take into consideration. And the result of this is this design right here. The resulting panel and design that they came up with, believe it or not, weighs half as much, and yet strangely it's even stronger than the original design. And I'm going to read you some facts here, even though you can't tell if I'm reading. Each panel installed into an A320 will save 55 pounds of weight, and that translates to about $40,000 in fuel savings for the life of the aircraft. That's per panel. Remember, there's more than one partition in an aircraft, so that's just for one. That saves about 500,000 metric tons of CO2 per year. Crazy. And that's literally like taking 96,000 passenger cars from the road. Now that is the power of generative design. And we're actually looking at helping them redesign the entire cabin now. And in case you think that I'm making this all, that they didn't take this into consideration, they did. They're actually testing it out now, and they're seriously looking at putting them in the next set of the A320 planes. You get a little bit of a video. We did notice that the videos on GoToMeeting are a little bit choppy, so I apologize to you on that. There's nothing we can do about that. There's one video that we did save separately so that you should get a better experience with it. And then this is, believe it or not, this is their view of the Airbus in the year 2050. The way it's way. And the population is 9 trillion, whatever. 9 billion. Look how much fun it will be to fly in there. All right, so that's not an AEC example. Let's take a look at an AEC example, where we're going to give the computer, we're going to do generative design. We're going to have it come up with the best possible office layout. And in this situation, we're going to ask it for some multi-parameter optimization using our Fractal project. And we're asking it to take some parameters into consideration, such as the travel distance to collaborate between teams, right? You want your teams together. The light and acoustic level, The visual and audio distraction at each desk, that's super important to me. I'm so easily distracted. And the natural light in the office. And then the views, the exterior views, you know, you want people to look at nice things. So given all this information, the goal was for it to come up with the perfect layout. And I'm just going to continue to apologize for the choppy videos. You get the idea. All right. So let's move on. So digital collaboration. So also part of the cloud, the ability, right, to collaborate with people all over the world. We've heard a lot about digital collaboration, the world of AR and VR. And I'm sure that many of you are kind of like, oh, this is all for games. This is silly nonsense, this whole AR, VR. I'm going to just give you a couple of examples that are not silly game stuff. Because that's what I was thinking too. This will never catch on. This is not going to go anywhere. I'm going to show you a couple of examples that you're going to totally want. Let's start by talking about AR, augmented reality. Okay, so you don't have to buy any expensive goggles for augmented reality. You're going to probably have a tablet though. And essentially, augmented reality, you are looking at the real world and you're just augmenting it with a digital image. You can see on the right-hand side, we're looking at the real world, but we've thrown in a digital image on top of it. Here's another example. Maybe you wanted to see what a particular cityscape looks on top of an existing city, for example. And I'm going to give you the perfect example of why you care. Here's the perfect example, but I got to set it up first, all right? So many of you have, grown up with these. Maybe you still play them, I don't know. What's the difference between the two pictures? There's 8 differences between the two pictures. You're supposed to go through and circle them all, right? If it's a live audience, your head would shake. And some of you would start pointing them out. That's usually the way it goes. Wouldn't it be so much easier if you could just put them right on top of each other? If they were 2 different colors, it would be so easy for you to see the differences, right? Okay, here's my AEC example for you. Okay, you guys, have you ever wanted to be able to see exactly, you have your model, you want to make sure that the contractor built it the way you spec'd it out, right? So you can actually walk in with your model and you can walk around and make sure it was built the way it was supposed to. So in this situation, the framing's in place, but before the sheetrock goes up, lay the model on top of what the camera's showing to make sure that all of the systems are in place so that no rework is going to be needed. Come on, that would be awesome. I know you guys want that. The perfect example of augmented reality. I know you want it. Here's another example. It has to do with asset management, people management. This is pretty interesting. So here he happens to be, he's looking at through the software. He is going to highlight an area in the real world, translating to the real world, where he's going to say that area is not safe. Let me know if anybody steps into that area. And here we have an offender. She's stepping into the area. You can see the lights are going off. And he's like, oh man, he is not happy. He's like, what's going on over there? He's going to walk over and he's going to confront her. Say, what you doing? She's like, I didn't go in there. What are you talking about? Even though the lights are flashing on my vest. So that's another example where you're reaching through the software into the real world and connecting it up together. And then virtual reality. This is where most people think, oh, once again, I'm not going to ever need to use this. So in this situation, you do need to have the goggles. In some cases, you can get away with the cheap Google Cardboard. I'll show you an example of that. With virtual reality, you have to construct an entire world. Augmented reality, you only need to construct whatever goes on top of the real world. So virtual reality takes more work. So that's Revit Live. And here's another example. So here's a gentleman that received an email asking him about something that was going on in the construction site, and using $10 Google Cardboard, he's able just to drop his phone in there and take a look at the construction and compare the model with the construction. That's also pretty amazing technology. So that also would be VR, virtual reality. Right? $10 Google Cardboard. We can afford that. All right, let's move on to reality capture. All right. So many of you are already doing this. You're scanning, doing some pretty impressive scanning. You're, why reinvent the wheel? If you can scan something and bring it in, if you're working with existing conditions, why not, right? We don't want to do any more work than we have to. This is, once again, also because of the cloud. So these scans are huge, huge, huge. You really need to harness the power of the cloud to take advantage of these scans. And this is a perfect example of it. Hopefully you'll be able to see this video, okay? This happens to be the Glen Canyon Dam. It impounds Lake Powell. It's actually the second largest reservoir in the country. And the Bureau of Reclamation asked Autodesk if we would help them scan this and create a 3D model out of it. All they had were 2D drawings, and they wanted a 3D model so they could use it for tourism, for security reasons. They had a variety of things they wanted to do with the model. And so we worked with them, and we scanned these images for them. It's pretty impressive. We captured 700 laser scans, 2,200 photos, all using it. And we used a recap. I'm sure many of you are familiar with recap. Probably many of you have used recap. But once again, that type of technology with those, millions and millions and millions of points, if you're not harnessing the cloud to work with those, very, very painful, right? Here's another example of, really harnessing the power of the cloud. And this is a situation with a company called ICA in Mexico City. You can see that elevated highway. This is a combination actually of an aerial, of a video and a Revit model there of that highway. ICA wanted to add in an elevated highway to alleviate the traffic below. And in order to do that, they actually ended up building this highway in the middle of the night because they couldn't risk shutting the highway down during the day. So it's a pretty intensive story. I'm just showing you parts of this, but I want to show you how they were able to plan everything strategically ahead of time, have everything down to the nth degree using the BIM 360 products. They were able to make sure that the cranes were going to fit in place. You don't want to get everything all set up and find out there's not enough room for the cranes. If you've ever worked in construction, you've all seen this happen at least once. Being able to coordinate everything ahead of time. And once again, they did this from like 1 in the morning to like 4 in the morning every night. Everything was prefabricated. All the rebar, everything was assembled, all off-site. And they just basically delivered it to the site and put it in place. It's crazy. All right, moving along, the Internet of Things, also something we get because of the cloud. We get a lot of data because of the Internet of Things, but how does it relate to you? Well, sensors are cheap, and you'll find more and more buildings are having sensors put into them, making smart buildings and smart cities, and we hear about that all the time. Our Boston office is a smart office, and this video I'm going to show you is actually from our Boston office. And I hope it's not too choppy for you, but here we have a scenario where we have a woman who's working in a section of our Boston office, and the temperature is just a little high. And because of the sensors, it sends information off to the various components to make sure that nothing is broken or not everything that's working properly. You'll see at some point it realizes that something isn't working quite right. You can see the temperature is definitely escalating there, and that there's a problem with the compressor. A ticket is actually generated. And you'll actually find that that's a repair request is issued, the maintenance man is sent out to the site. He can find all the information that he needs about the repair manual. He can open up models. And you'll see that he fixed it. Everything is beautiful now. The temperature is down for her. Oh, she can get so much more work done now. She's smiling now, although I think she was smiling to begin with. But you'll find more and more intelligent buildings and intelligent offices and, of course, smart cities as time goes on. All right, so the era of connection. We talked about the era of documentation. I mentioned to you about introducing AutoCAD into the world. You know, everybody was drawing on paper, and then here comes this land of CAD, very disruptive, but, you know, was definitely eventually embraced and became very successful. And we call that at Autodesk the era of documentation, right? We were able to, you know, document our drawings to, you know, 8 places to the right of the decimal and create incredibly accurate documentation. And then we have the era of optimization, where we are able to, you know, make the move over to BIM and start to create, you know, intelligent buildings. We're able to add so much information into our models and really take it to the next level. And now we believe we're going to kick it up to that next level with the era of connection. And that's what we're here to talk about today, where we're fully embracing all that the cloud has to offer and create those connected BIM workflows across the project lifecycle. So let's talk a little bit about that. That's probably what most of you thought we were going to be spending the full time on today. So I want to make sure that we fully address that. So the old way of thinking. So this is the way most of us have done this. You know, you made the move to BIM. You adopted the software to help you be successful at BIM. You've installed it onto your computer. You installed it onto, you know, maybe your mobile devices, depending on what you're doing. And then you create your models. You save files. You know, I'm not really sure where you saved them to. Maybe you're locally, or you might have saved it onto your company server, whatever the situation is. And then you send the files to people. Right? That's what we've been doing for a very long time. And then everybody does it the same way. Everybody's sending all these files around. And it can cause a lot of chaos because you run into issues as to whether or not, you know, do you have the most recent information? You know, if you've ever been in a situation where you're wondering, is the superintendent know whether the version is current, is a subcontractor foreman working on yesterday's plan, you know, where is the most up-to-date information and who's got what, and it can get very, very confusing. So yes, you know, you've embraced technology, but this technology has added to some additional issues and eventually to data loss. So we need to step it up. We need to move on to this era of connection. So what we want to do is we need to focus on this new way of thinking where everything is project-centric. And I can't emphasize this enough. We need to focus on this single source of truth, this one-centric model. This allows you to have version control. It allows you to have all different types of capabilities that we didn't have before. It will make sure that everybody's working on the most recent information, right? I mean, we're not just building software for the handful of people in the office or the trailer. We're providing technology for those 220 million workers that span our projects, right? That's our goal. We need to make sure that everybody is on board and everybody has the most up-to-date information. And that's really where you get into collaboration for Revit. That's where you get into the BIM 360 tools. And this isn't a presentation on BIM 360, but I want you to file that away, BIM 360. I want you to, because you're going to hear more and more about it. If you're not already using the BIM 360 tools, I want you to start thinking about it, and I want you to, you're going to hear about them, and I want you to start to embrace them, because that's going to help you move to that era of connection for sure. And I'm going to give you a couple of great examples of that. This is my favorite example. This is a U.S. Bank Stadium. This is in Minneapolis. The general contractor was Mortensen. And this is the Viking Stadium, right? So whether you're a Viking fan or not, it doesn't matter. This is a very cool stadium. I actually was visiting here not too long ago. It has a massive transparent roof and the 5 largest pivoting glass doors in the world. Who knew? Okay, I didn't know that was a thing, but it's a thing. So one of the great things about this project was that the construction team had visibility into the BIM model before construction ever began. So they were able to build the entire stadium virtually, right? Before they ever broke ground, they knew exactly what they were going to do ahead of time. So every single steel embed plate, along with many other MEP systems, were as built to determine compliance. So they were able to eliminate the problems before construction ever began, just like you saw also before on that ECA project. So they were able to figure everything out ahead of time so they didn't run into emergencies on site. And my favorite part of this is that they created a map of concrete pours so that every pour was in the correct location, and there were 1,500 of them, 100,000 cubic yards of concrete. It's crazy, crazy, crazy. It was incredibly detailed, and they got it right, and they got it right. And I have some nice facts and figures for you here. 60,000, they had 60,000 points in total that were entered into the master model. Okay, a lot of work. I'm going to agree with a lot of work, but boy, it sure paid off. They use BIM 360 field. Once again, but I want to hone in this whole BIM 360, just in general. Just keep that in the back of your mind. BIM 360. That's going to be my takeaway for you. 20,000 items are managed through BIM 360 field. That helped them, plan everything out ahead of time. And they did get everything done 6 weeks ahead of schedule. And this particular stadium was built for hundreds of millions of dollars less than other stadiums. Significantly less expensive. And you know what he did with all the money? All the money that he saved, did he save the money? No, he went out and he bought 2,000 high-definition flat-screen TVs that he put up in the stadium to enhance the viewing experience. See? That's what you do with the money. You buy TVs. Who knew? So connected BIM, once again, connecting everybody on the design team, the design, the build, the operate, everybody connected together. We have all this technology. We need to make sure that everybody is working on that single source of truth. Remember, once again, it's BIM plus the power of the cloud. It allows you to do so much more than just the software allows us to do. There's the collaboration aspect of it. We talked a lot about that. The continuity, there's that single source of truth once again. And the insight that the cloud brings you. The ability to make intelligent, informed decisions, smart decisions, which ultimately leads to saving money and time. So disruption. I shared with you quite a bit of disruptive technology today. A lot of disruptive technology. Some of you are going, she's crazy. I'm never going to embrace that. But I hope that there was some technology today that you said, wow, I wish I had that. I love that. Or that piqued your interest, at least for you to take a look at. And I just like this phrase, disruption is good, but ignoring it is bad, very bad. And we've seen in our lifetime that ignoring some disruptive technologies and not embracing it can be bad. And so I definitely encourage you to, keep your ears open and be aware and continue to move forward in your journey of BIM, and definitely to embrace BIM plus the power of the cloud.